Good morning, everybody. Hello and welcome to the Symposium 29 Specify Spotlight. My name is Grant Fitzsimmons and my co-moderator is Theresa Miller. We're both staff at the Specify Collections Consortium. This was made possible thanks to the generosity of our sponsors and our diamond sponsors, and we're grateful to them and these wonderful folks from OK Congress for providing tech support. This session will be recorded for later viewing on the YouTube channel, and if you have any questions during the meeting, you can send them through the Zoom channel and we'll read them aloud, or if you're in person, please come up to the microphone and speak. Each one of our presenters today is going to have about 13 minutes of time to talk, and we're going to leave a couple of minutes for questions if possible. And if you're attending virtually, like I said, just send that message and we'll come up to the microphone and speak for you. Just please enjoy the session. And first, we're going to have the folks from CSIRO come up and talk. So that'll be Corinna and Zoe. So for them in particular, please wait till they've both finished speaking to ask your questions. Okay, thank you so much.
I do not like microphones. Hello, everyone. Thanks for attending this session. My name is Corinna Paeper, and I'm the team lead of the National Research Collections Australia Data Management team at CSIRO. And today I want to talk to you about how we implemented Specify across multiple national collections at our organization. So very briefly, who are we working for? So we're part of CSIRO, which is Australia's national science agency. The National Research Collections Australia, or NERCA as I like to call it, sits within a business unit that hosts other important programs, such as the flagship research vessel, the RV Investigator, and the Atlas of Living Australia, that no doubt many of you know. So NERCA houses six of Australia's major biological collections, comprising of around 15 million natural history specimens, which are generally accessed by researchers, government and industry bodies to describe, manage and utilise Australia's rich biodiversity. So to give you a really quick rundown of our holdings, so these are our 6 collections there on the screen. So we have our fish collection, which has about just shy of 100,000 records database currently. That's a mix of specimen records, tissue records and x-rays. Our wildlife collection over here, edging on 250,000 records. Same, a mix of specimens, tissues, and a pretty big sound collection as well. Our herbarium, which is actually 3 collections, totaling about 1.4 million records. Insect collections, some of you who have heard David's talk yesterday might look at the number and go, hang on. This is what we currently have databased. So out of about 12 million plus specimens, we only have about 3% databased at this point in time. We also have an algae collection, which has about 1,000 strains, and a tree seed centre, which is mostly a commercial endeavour, which provides well-documented seeds to the public and commercial enterprises as well. Now, these 4 collections that you can still see are the ones that we migrated across to Specify. So what did we do? As I just mentioned, we moved 4 of our main collections over to a unified digital platform, Specify, and you might ask, why did we do this? So one of the things in CSIRO is we actually have about 50 collections across the organizations that hold physical specimens. The management, preservation and curation of these collections has historically been independently managed by the group who is looking after the collection. And particularly in the case of our biological collections, each of these had separate and aging management systems. So NERCA embarked on a 3-year collaborative project which was aiming to establish a standardized approach to managing CSIRO's biological collections in the first instance, but then also hoping by establishing this more as a CSIRO service, that over time other collections would come online as well with Specify. So basically what we're trying to do, we're standardizing the way the collection data is managed in an enterprise level system. We're trying to increase the system reliability and security, and we're also trying to improve the access and discoverability of the data through pipelines to our biodiversity aggregators like ALA and GBIF. So how did we do it? The big picture. We did this in 2 phases over a 3.5-year period. We started off with a 3-year project. As usual, it ended up being a 3.5-year project. We started off with the smaller collections, the wildlife and the fish collection, which went live at the end of 2022, and then started working on the insect collection and the herbarium, and they went live at the end of 2023, and in July 24, so just 2 months ago, for the herbarium. Also want to note that the herbarium took a bit longer, not only because it was our biggest collection, but also we built an integration pipeline between the Specify instance and our living collection system, so these 2 systems can interchange data. Now, this was not just a 2-person job. We had a pretty dedicated and big project team. We're talking about product owner, product managers, BAs, testers, developers, of course the data management team, and SMEs from each of the collection at the given points in time. The migration process pretty much followed a structured approach of give or take 5 phases. We had some high-level planning, data modeling and mapping stages, building of a data migration pipeline, including data verification. Data cleaning was sort of iterative, built into the whole process, and that was then followed by the actual implementation, migration, and transition over to a BAU environment. What did that mean on a day-to-day basis? We had daily stand-ups to keep things moving. As a side note, Scrum Agile does not work for data migrations. We tried for many weeks, and we eventually settled on a Kanban methodology, which seemed to be much better suited to the task. We had lots of regular scheduled meetings with our collection SMEs, particularly in the data mapping phase, to make sure everything maps nicely to the Specify schema. Lots of project lead meetings, lots of unscheduled meetings with various people, depending on the phase of the project we were in, lots of additional communication on Teams, and standardized processes. So they really became important for us. We had Jira boards, 1 for each phase to track where we're at. We had a Confluence page for documentation. We had spreadsheet templates for data mapping and the migration feedback, which I'll show you in a second. And most importantly, I think we used an ETL tool, Pentaho, to actually do our movement of the data from source to the specified database. And with that also came a data verification step. This is a bit more technical. So all of our Specify instances are located on CSIRO's on-prem servers with 1 instance per NERCA collection. We have multiple environments for each of these instances to help the testing, UAT, and development efforts. We still have those instances because we're still playing around a lot. And we had a general high-level migration plan, which was adjusted to the details of the collection we're just working on, mostly during the planning and data mapping phase. And a lot of these things were orchestrated by Jenkins. So in a simplistic way, basically our migration steps were collecting the source data and moving things into an interim source database. So in some instances, we had multiple databases, legacy databases. We had spreadsheets, so we tried to get everything together into a single database, which became our source of truth. Then we had our pipeline here, which included all the mapping and all the transformations that needed to be done to the data to load things into the specified database. And that colloquially we called a migration run, basically, when we hit the button and data was moved from A to B. One of the important steps was our data verification, because things can and will go wrong in your ETL pipeline. We learned that really quickly, so we ended up building a couple of access databases that pretty much mirrored what happened in the ETL tool as an independent checkpoint. And that, I'll talk about that a little bit more in a second. That really became crucial to make sure that all the data that we needed to go into Specify actually ended up in Specify. So basically we then just did a rinse and repeat of migration runs until we couldn't find any more issues in the data. And at that point we then did our final migration run, did final testing, and went into BAU with that collection. So just very briefly, some of our tools. So as I mentioned, we use templates quite a bit. So for our data mapping step, we utilized an Excel template that was reused pretty much for each collection that we migrated, and that became our source of truth for everyone working on the project, the testers, the developers, the data management team, everyone. It's a pretty big and wide spreadsheet. It has quite a few sections to help us capture the various elements of the process. So obviously the crux of it is our current database mapped to Specify. And as you can see, maybe, there's a whole heap of additional fields that just helped us track things in terms of making some notes and how confident we were with the mapping and any kind of actions that we needed to take. Some of these collections, I think our biggest one had about 700 fields that we needed to go through. I think only about 250 eventually ended up in Specify, but you still need to look at everything to see whether it needs to go across. We had a notation to say we need a pick list, or this is a mandatory field, or this is a default value. We had some checking on whether any transformations were added to the ETL tool and the data checks. We had a section that allowed us to record whether we had transferred everything into Specify, whether that was in the schema or on the forms. And we also noted what sections on a form fields were on, because that allowed us to make a quick spreadsheet for the new users to try and figure out where their old fields are now located in Specify. Now, as I mentioned, the data verification became quite important to us. It pretty much was an integral component of the data migration process as a whole. It basically functioned as an independent checkpoint, as I mentioned before, by mirroring the transformations that were executed within the ETL tool. And the process helped ensure that the accuracy of the data transfer from source to Specify was actually completed accurately. And we basically did this on a record by record, field by field basis. Every single field for every single record was double checked. All we did was directly querying the source, querying the Specify database, and then comparing the outputs of each places after any extra transformations had been applied. For 3 of the collections, we utilized Access. One, we had to use a SQL-based approach because the data volume was a bit too big for Access. And just a couple of screenshots. This was our ANIC one. Really simple UI, just put together a couple of macros that allowed us to execute the various bits of the data checks. This was a very high level check where we basically just put out all the tables and said, oops, there's a delta, we better check out why we have more records on one side than on the other. A very high level overview where we're just getting counts. Now, I struggled to find some decent examples because obviously everything should be clean now. But this was one example here. So this is not a great example because the numbers are low, but particularly in the beginning, you often end up with thousands of records, so it really helped the troubleshooting to have that high-level overview. And then much further down, you get the record by record with left side, right side, actual values displayed. Now again, I couldn't find an actual example. These are some of the test records we put in to make sure the Access database actually works. Really quickly on the migration feedback spreadsheet, so a very similar concept to the data mapping one that I've showed earlier. Also was the source of truth for any issues we found in the migration run, so that could have been anything we found through the access checks, UAT, random testing in the UI, testers, SMEs, the data management team, anyone really who was playing around with the data once it was in Specify. A bit simpler than the data mapping one. It was just which migration one was it, who reported it, a couple of details. At a later stage, we added in prioritization, impact, and estimation of time to fix the issue. That becomes quite important when you're starting to run out of time, because you can just sort things as needed. And then also he was responsible for actually actioning things. We used a lot of pivot tables with this one, because again, it gives you a quick overview of where you are at in the process. Now, some of you might wonder why we didn't continue with Jira. This was a much easier way to keep an overview of what's going on. We did go into Jira as soon as we had something that became too big for a quick note in Excel. And then we recorded that there was a Jira ticket in that spreadsheet. So what did we achieve? After 3.5 years, we've migrated just over 2 million records into 4 Specify instances and a total of 10 Specify collections. And as you can see there, our herbarium is by far, at this point in time, the biggest collection. So really, really quickly, a couple of lessons learned. We found that processes are important when you do this at scale. So these templates and Jira boards and Confluence pages are really, really helpful if you do this process over and over again. Grant touched on this yesterday in his talk. It takes longer than you think. So with the data cleaning, you do need to draw a line at some point. And what we found the best is to look at what you need to clean and figure out the things that are easy to clean and specify at a later stage, and those things that are much easier to do through the ETL tool. And then you just create a running list of all the issues that need to be resolved once you've gone live. As I mentioned, Agile does not work for data migrations. The additional data validation is crucial, we think, if you don't use the Specify workbench. Testing, again, something Grant talked about yesterday. The buy-in from the people is super important, and also training your SMEs as early as you can. Now, I'm almost done. Just almost hand over to Zoe. So now that we're in Specify with 4 collections, you might wonder how we do our support for those 4 collections. So Zoe will be talking about that straight after me. And to end, just really again reiterating that this was a big team project. Now, not all of these people were working on the project for 3.5 years, but it was a lot of us. So yes, thanks for listening. If you have any questions or want to know about any of the details, talk to Zoe and me. We're here until the end of the conference, or you can always contact us at Specify Support at CSIRO, not to be confused with the Kansas Specify Support email address. We will forward them to Specify if need be. Thank you.
Thank you. So I'm Zoe, and Corinna just went over what we just did, and you'd think, done. but no, how are we managing the system moving forward as a BAU project now? So central to that is the data management team. So it's really key in how we support our collections. So we have a centralised Specify support team who provides administration and expertise in the system and also provides data management and analytics services for the collections. So the team consists of 3 people, which Corinna mentioned, Dan, myself and her. And we work across all the collections. We don't just work in one each, so that we can spread that knowledge and reduce single person dependencies. So how do we sort of practically approach support as well? So we've sort of developed this support services portal. So it's a website that we've built for users using WordPress. And we have a general website that has our training videos and cheat sheets and other useful links. And then we have also the instance-specific support websites that have information relevant to that instance. So this is just a screenshot of the general website, and along the top you can see the links to the actual Specify 7 instances for each collection. And then down the bottom you can see our different support services. So we've got a contact point for us, our training materials, so the videos we've recorded, cheat sheets, and we've also got links to the actual Speciforum support documentation that the consortium maintains as well. The collection homepages is the actual collection-specific support sites. So this is the Herbaria homepage. So again, you can see we organise things through those tabs. One of the first ones is the queries. So we pre-build Specify queries for each collection so that users can just jump in, click on these links and open a query and run them and get their data based on the description. They can also play with those queries and change them and save them to their own accounts if they want. And they can always come back here if they've stuffed up and just restart their builds. You can also see this is where we keep the workbench templates and the mapping plans that we've built for users for the bulk data entry work. And then we have a lovely miscellaneous page as well, which contains other documentation specific to that instance. And there's that data structure document that Corinna mentioned in the first talk, which is where we've mapped out all the data fields and tables for that specific instance, for that collection, so they know where the data sits and they know which table they need to go to get a particular field, which is really useful when they're getting used to the system and when they're starting to build queries, so they know which little chain of command to go down when they're starting to build those more complex queries. So regarding the management of our users, we have about 130 users now across the 4 instances. We manage them through 4 standard user roles. So even though you could go down the route of bespoke access levels for each user, that would just be too much admin. So we've created these 4 roles in consultation with the collection managers. So people are granted access per instance and at the consent of a curation manager. So we don't just let anyone have access to Specify. They have to go through the checks with us and the curation managers. We have ongoing regular check-ins with the collection managers. So weekly, fortnightly, we just run through things, any issues that have come up, any potential data analysis that needs to happen, any tweaks to the front-end forms or the reports or the labels and things like that. So obviously a big part of support is actual user training, and we go heavy and hard when we onboarded the collections initially, and we ran multiple introductory sessions for each collection, and it was geared specifically for that instance so they could get used to their data in that instance. And we really focused on getting them to understand the relational database concept and the use of queries, because we wanted them to be able to go in and find what they needed pretty quickly and to get comfortable with the system that way. Additional training following that is generally collection agnostic, because the underlying systems and processes are the same. It's pretty easy to provide these sessions and then just swap in screenshots according to the instance if needed. And then we record those sessions and put them up on our website that I mentioned at the beginning. As part of the Herbaria onboarding, we ran some virtual drop-in sessions through Microsoft Teams, and they were really, really useful. So people could essentially just jump in and ask a question of the team, and then drop out if they wanted to and go on with other things. But we found at the beginning, actually a lot of people popped in and stayed and chatted and worked through various questions that each user had together. And it was a really nice way of building the community for that particular instance. And because they were so successful, we are thinking of implementing them for our users in general, doing sort of weekly or fortnightly drop-in sessions. And we also want to run some specific user workshops later down the track for NERCA. So yes, things can go wrong, and we want our users to be able to get in touch with us as easily as possible. We also want to make sure that they're getting in touch with the team as a whole and not individually contacting a particular person. So we have a dedicated Specify support email that Corinna highlighted. And that contact form on the website actually goes to that inbox as well. And then we have a Microsoft Teams channels. So we have a overarching channel where we can sort of make announcements about the instances if they're down, or if an upgrade's coming, or if there's some training being held. And then we have specific channels for each instance as well, where people can ask questions relating to that instance. And they're really good, and we're taken up by the Herbaria again. They're like our super users at the moment, which is great. And it's really, again, a nice way of building that community. And because everyone sees the question and everyone sees the answer, so you're not repeating yourself. And also users are actually starting to help each other through that forum. And that's really great because it means they're not solely reliant on us and they can help each other. But obviously we still have oversight, so if we can jump in if needed, if someone maybe gives a bit of a wrong steer. So having a centralised support team is really important when things go really wrong, because we're the single point of contact. We can collate the issues and assess the impact across the collections, prioritise what needs to happen, and then obviously disseminate that update to users and information to users. We're also the single point of escalation to our internal IMNT team, who actually provide the technical infrastructure to host our databases and also deploy upgrades and also back-end edits and things if we need it to the system. We're also the single point of contact for the Specify team in the US. So we've got an established channel of communication with them, so we can go through and ask them any questions, raise any issues that we can't resolve ourselves. Often that reveals feature requests that we can then prioritise according to the whole NERCA collections rather than per collection. And in that respect, we really do encourage our users to give us feedback on the system, because we want to know where they're finding pain points and where we perhaps can help them work better in the system, and whether that might need to be a feature request or not. With the caveat that we tell them sometimes things are easy to change, sometimes they're not. Patience is a virtue. And then regarding upgrades, we do that in a coordinated fashion. So we want all our instances on the same version at the same time. Now we've moved into the BAU phase of this enterprise system. We haven't quite figured out what our release cycle will look like, because we are dependent on the IMNT resources within CSIRO to do those upgrades. And they have limited time available to do that. So that means we have to sort of take a considered approach. So at the moment, we're keeping a running log of the releases that come out from Specify and sort of keeping track of the benefits that they may provide to us. And then when we reach that critical tipping point where it makes sense for us to upgrade, we'll then book in a time with IMNT to do the upgrades as needed. So some of the established benefits that we've already seen in 2 months of being all the collections in Specify. We've obviously established a team with great Specify expertise, and also some of the subject matter experts in the collections also have great expertise now as well. We've managed to build data checks for all the collections, and we can do that in a consistent fashion because the platform is the same. So we can manage them all the same way. And this is true for data exports that might go to the ALA and then downstream to GBIF. And also for our bulk data input pipelines. So we're using the workbench across the collections, and we build those templates and do the mapping plans for users. And we do them in a way that's consistent so that we can maintain those standards. This is just an image of one of the data checks that we do for our fish collection. So actually the document has multiple checks in it. This one just happens to have 3, and that's a zoom in of one at the bottom. So that's missing a tank and drum number. So if a user goes in and fixes that record, then refreshes this data check, that catalogue number should then not appear. And this is an example of some of our workbench templates for ANIC. So we've actually put validation checks within the template itself before it even hits Specify to try and maintain that data integrity. And then we've got additional sheets within the template that sort of explain the template itself and what the user needs to do a bit to fill it in. Regarding what the future may hold, the opportunities that a centralised team and a consistent platform across collections means, we really want to look at building some statistics dashboards for CSIRO internal use that provide figures based on each collection, but also on cross-collection analysis. So we can further support this biodiversity research that NERCA is doing. Specifies pretty key part in linking or closing the loop between the physical and digital extended specimen. So that will involve the interchange of data between Specify and the platforms that hold these digital assets. And then finally, a bit further down the track, we would really like to build on the workbench capability and improve field data digitisation processes so we can close that time gap between when something's collected and when the actual data is entered into the system. So that is me and Corinna and what we've done with Specify. Thank you.
I don't think that there's any time for questions for that, but thank you so much. You can find them both here all week if you have any follow-up about CSIRO's work and Specify. And their email, Specify support. All right, next we have Alison with the Royal Botanic Gardens, Victoria.
Thank you. Thank you. So today I'm going to talk about the way that we use collections in Specify to manage our incoming exchange data at the National Herbarium of Victoria at Royal Botanic Gardens, Melbourne. The herbarium, hang on, where are we? This one. The herbarium sits on Wurundjeri Woiwurrung country in Melbourne, just on the edge of the Botanic Gardens. So like many herbaria, the National Herbarium of Victoria has an ever-increasing backlog of specimens awaiting curation and databasing, including over 13,500 specimens received as exchange from other herbaria. We've very recently, just last month, reboxed and reorganised all of this. So we've got these big towering walls of specimens, which are a bit overwhelming. But because these exchange specimens increasingly come with digital data, Our workflows for processing them are a bit different from those for specimens that we're databasing from scratch. I'm going to just go through those processes really quickly. They're probably not, it's probably reasonably similar to what happens in other herbaria, and I will just provide the caveat that it's never actually this straightforward. This is a very generalised process. The flow chart is usually got arrows looping back on itself in reality. So specimens that are already in our collection are usually just a matter of transcribing the data from the sheet into Specify, assigning a catalogue number, and then sending the specimen off to be mounted by our team of volunteers if it hasn't already been mounted. Specimens collected by our mycologists and botanists generally have their collecting data transcribed from field collection books into either a worksheet, Excel spreadsheet that we've formatted to match our specified data model, or either directly into the database itself. They're also assigned catalogue numbers, labels are printed, and then the specimens are sent off to be mounted. Exchange specimens that come with digital data have a couple of extra steps. The first step, sorry, I went backwards there. The first step is to validate the CSV file that we receive. So although there are standards and although people exchange standardised data, it always needs a lot of validation and manipulation to get it to fit. So we might need to do things like delete species abbreviations from taxon name fields, or pass collectors out into individual columns and surname, last name, surname, first name. We might need to pass locality information out into country, state of province, and locality description, or pass the georeferencing information into different fields. We would then assign a catalogue number, preparation type, preparation quantity, and any other required fields before uploading that data into Specify via the workbench. So once the data has been uploaded, we match up the physical specimens with the database records and double check that everything is in the right place. So even though we've done that spreadsheet, the CSV level validation, if there are fields like that, if collecting notes and descriptive notes and things have been merged in one field, it's really hard to get all of that right at the spreadsheet level. So we need to, once it's been uploaded, we need to eyeball it and make sure that everything's in the right field, make sure that nothing's been missed. We also need to make sure that, sometimes there are not catalogue numbers from the sending institution in the spreadsheet, so we'd need to add those. At this point, it's also really important that we check that there is a physical specimen that matches the data that we received in the spreadsheet, because it's not at all uncommon to receive a different number of records in the spreadsheet than there are specimens in the box. So we want to avoid creating database records for specimens that we don't actually have. These specimens are then added to our mounting backlog. But the mounting backlogs aside, and regardless of the source of the specimen, whether it's a legacy collection, something freshly collected by one of our staff, or an exchange specimen, once the collection object record has been saved, at the end of each week, it's Friday about 7 p.m, I think, looking at Neil's, that all of our data is published to external aggregators. So for us, it's to the ALA and AVH, and through them to GBIF. So while that quick delivery of specimen data to those online aggregators is fine for legacy collections or things that have been collected by staff and have been the data's been captured in line with our data model in the first place, that's okay. It's not a great system for the exchange specimens. Because with large batches of exchange specimens, there's always going to be a delay between uploading that data and actually getting around to verifying it. So we don't want to end up with publishing records that have errors in them, or publishing records for specimens that we don't even have. So that's where the collections in Specify come in, and we use that to validate the data and give us time to do that cross-checking. So as you're probably aware, the Specify data model accommodates varying levels of administrative levels within the data model. Sorry, I'm getting all confused. They're hierarchical, so within an institution you can have multiple divisions. Within a division you can have multiple disciplines, and within a discipline you can have multiple collections. And while the original intent of this by Specify was to accommodate multidisciplinary institutions, it allows you to be quite creative and flexible in the way we use it. So we have several different collections within Specify. The National Herbarium of Victoria, we're going to get a question about that one, aren't we? The National Herbarium of Victoria is our main one. That's the one that all database users can access in varying levels of permissions. And that's the one that the data is published to external aggregators from. We also have a couple of collections that are used in the way Specify intended, so for physical sub-collections within our institution. So the Victorian Conservation Seed Bank and the Victorian Reference Set, which is used by our ID service. But then we have our incoming exchange collection, and that's the one that we use as a holding database. So the way this works is that when we receive digital data with consignments of exchange specimens, instead of uploading it directly into that National Herbarium of Victoria database from where things get published, we instead upload them into this incoming exchange database. You note here that this example, you can see it doesn't have a catalogue number yet, and that's quite important. Then, when time and resources permit, we can get the specimen in front of us. This is a bit misleading because it wouldn't be mounted at this stage, but it was a convenient image to use. We can look up that exchange specimen via the sending institution's catalogue number or the collecting number. At this point, we double check that all the data is in the right fields, and we assign a barcode label to the sheet and then scan that barcode into that collection object record, into the catalogue number field. Each night, a stored procedure transfers any collection object records from the incoming exchange collection that has a catalogue number into the National Herbarium of Victoria collection, where it can be viewed by all user groups, and then it gets published at the end of that week. Won't go into too much detail here, but you can see, so this collection ID 163840 is the collection ID for the incoming exchange database. So it's looking up records in that collection where the catalogue number is not null. So it doesn't do anything at all with the specimens in the records in incoming exchange until they've been given that catalogue number. So there are several benefits to this process for us. It allows us to verify that we have received a physical specimen. We can validate the data before it's published. It gives us flexibility in our curation processes, so we can schedule this work amid other priorities. And that flexibility in turn allows us to use volunteers to do this checking work. So we have a big cohort of volunteers, but they come in for a few hours a week. And so if we were trying to rush through this to get everything checked before it was published in the National Herbarium of Victoria collection, it just wouldn't work. But this way we can just sort of slowly work through that with volunteer assistance. And perhaps most importantly, in terms of collections care and mitigating the risk, separating the data upload from the final data validation and publishing steps reduces the risk of dissociation. So we can get the data uploaded when we receive it to safeguard it against loss or corruption. So that's it. Just want to thank the Specify team for all the support they've given us over the years, and Niels, my co-author, is over there, and to Catherine Gallagher and Namal Karanajira, our colleagues at MAL, who look after both the specimens and the data for this stuff. Thank you.
All right, I think we have time for at least one question. Elspeth, you seem like you had a thought about that collection.
I've got two questions. Two quick questions. So one is, and apologies because I should know this and I can't remember, is for different collections, do they have different trees, or do they use the same tree?
They share it across disciplines, I
Shared
think.
trees. Super.
Yeah,
Thank you.
yeah.
That was a quick question. And the second question, it's got to be asked.
Yeah, purgatory.
Purgatory.
Okay. So last year, while we've got a team working on our non-Australian collection, so a third of our 500,000 of our specimens are collected outside Australia. And they were working on the non-Australian Ascomycetes, and at the end there was this box of stuff, and it included a specimen of Bacillus anthrax. So we had to do something with that. So it's now on permanent loan to our sort of equivalent of the Centre for Disease Control in Victoria. So, but to be able to send it on permanent loan, we needed to database it, but we didn't want it to show up in the online aggregators. We didn't want anyone thinking, well, we can get some anthrax at the herbarium should we want to. So that's what that collection is for. And it's in its own discipline, isn't it, Niels? Because we didn't want to have to put a bacteria to the taxon tree for everything else. Or was it shared?
It's actually in the same. It's a collection in the same discipline.
Okay.
For us, the discipline is botany, but you can actually set the tree, the taxon tree, and the geography tree for each discipline, and we have set it so that
they're
every
shared.
discipline, all our disciplines use the same tree anyway.
Yeah. And so Niels named that collection when he entered the record.
Thank you.
Thank you. No.
All right, next up is Robyn.
Okay, so another herbarium talking about their use of Specify. I promise you there are other collections in Specify, it's just the herbarium showed up today for this one. So I'm from the Botanic Gardens in Edinburgh, and we migrated to Edinburgh to Specify in 2022. So we've been in for just over 2.5 years now, I think. Maybe 2 years, I can't quite remember. So we're going to go through a few of the ways in which we've been integrating Specify into our workflows in the collection. So just a very quick introduction, and then we'll get into how we're using Specify. So the herbarium at Edinburgh is based within the Botanic Gardens. We have around 3 million specimens, but we're not quite sure. We're working on it. We've databased around 1.5 million, and we've imaged 1 million. About a month ago, we hit 1 million images, so that was our big achievement this year. So as we're working through, we didn't have a catalogue of our specimens, so this is why we think we've got 3 million, and as we're getting them barcoded and databased, we're getting a clearer idea of what our holdings are. So we use Specify for the management of all elements of our collection, which covers herbarium sheets, the cryptogamic packets, so lichens, mosses, fungi, alga, our carpological collections, our liquid preserved material. We just moved our silica dried collections in the last couple of months, and we've got a small number of microscope slides, and we'll be working on bringing the other ones that we've got databased in, hopefully in the next year or so. so that we're ready for when we tackle the larger proportion of our slide collection. And we're also using it for all of the day-to-day management, including the accessions, which we often refer to as registrations, because our living collection has accessions and we didn't want a confusion between the two. So if I switch between them, that's why. Our loan and borrow transactions, destructive sampling, gifts, and permit records as well. So it's sort of used for everything that we need to manage the herbarium on a day-to-day basis. So I'm going to go through, I think, about 4 ways in which we've been embedding Specify into the workflows at the gardens. And one of the first things is the collection object preparation relationship. So this is a decision we had to make at the point at which we chose to migrate to Specify. In our old CMS, we had 1 specimen record per specimen. So if it was over 4 sheets, we would have 4 separate specimen records with cross-referencing between each record to kind of link them together. What we decided to do when we moved to Specify was to bring all of those different preparations under that single collection object. So we could have multiple herbarium sheets, some silica material, some spirit, and if we've done any destructive sampling, that would be visible as well. And we can have quite a lot of material. We have a lot of gingers. They often go over about 7 sheets and have spirit material as well. So it can be quite a lot of different preparations represented. But this has been really fantastic for our curatorial team. It now gives us that one place to go to see exactly what holdings we have for a particular collection. We no longer have to database or at least copy over data 4 or 7 times for different specimen records. And it means if we have to update something for any one of those specimen sheets, we update everything at the same time. So there's a much better data management in some ways for that. Before, you had to be aware that there were additional sheets and you would have to make sure you picked up everything in that umbrella. So this has been really helpful for a curatorial team, as I say, and if we're doing things like destructive sampling, we can now see if it's been granted before. If it has, maybe there's that data available on a resource that the requester could take advantage of. So this is sort of, I guess, key decision we made at the point at which we chose to migrate, and it's been really beneficial to how we're currently managing the collections in the gardens. The move to Specify allowed us to bring our permit management within our CMS rather than sitting alongside our CMS. And this has been really beneficial for us getting on top of those restrictions and the data that are associated with our specimens. So, so the permits and any of the other sort of access to the material information like the MTAs and MOUs are stored in the permits table, and then in the accessions table we have a very simple there are restrictions or there are no restrictions kind of toggle. So at a glance you can see actually I can do whatever I need to with this specimen, there's no restrictions on it, or if there's restrictions there's a text box underneath that you can put a summary of that restriction in, and then if you need to dig in further you can then just click through the single link to the full permit record where all of the documents are attached. So it's a very easy workflow, and that's to get to the accessions. It's 1 click from the collection object. So it makes it much easier for our curatorial team and our registrar to start understanding what they can do with a specimen when someone requests, for example, a destructive sampling record. This one's been fun. It's one of the more challenging elements that we've had to deal with. We're very lucky at Edinburgh. We've got a fantastic cultivated collection, primarily sourced from the plants within our gardens, but it also includes a lot of other material that's grown in cultivation and has been integrated into the herbarium. In our old system, the living collections and the herbarium collection were held in the same CMS, so bringing data between the two was really simple. You could just make those links and it would provide you with the accession information. When we moved to Specify, we moved our living collections to a separate CMS. So we had that initial separation of the two. So we had to find ways to start linking both to the living collection, which we're doing by including a link to the accession number with a web link to the to the online catalogue for our living collection, but we've also potentially got 2 herbarium specimens, or maybe even more. And this is where we've got this concept of multiple collecting events. So if we were out in field work, we could make a specimen. So we would have a herbarium specimen for the collection. At that same time, we might have collected seed or a cutting, and that would be brought back to Edinburgh and grown on in cultivation. At some point in the future, that might be collected to be vouchered for the herbarium. And at that point, we get a second collection in the herbarium. So we're treating these as very much as the 2 separate things, but there is a link that we want to maintain. So we're tending to do this at the moment by putting the catalogue number of the wild collection in the cultivated collection record. And this allows the specimens to have their own lives within the collection. Different things can happen to the 2 elements, but we've still got that tie between them. This has, as I say, been challenging. It's not perfect, and it's something that we're still working on. The collection-object relationship, which I can't think if it's out yet or if it's coming soon. And I think coming soon? Soon. It's something we're going to be exploring to see if this can help us with managing these 2 different elements. When the cultivated item is not one of Edinburgh's cultivated items, we treat them slightly separately, potentially having a dummy data record if it's needed to provide that wild information for the cultivated record, because we always want to maintain the wild part of the cultivated specimen's history as well. So it's been, it's quite a complicated one for us to manage, and the cultivated collection does make up a good chunk of the collections in Edinburgh, and they are really important to us, and they're increasingly of interest for humanities research and a lot of other research questions as well. And then the last element that I wanted to talk about is we've done a few things sort of alongside Specify that really help to facilitate our workflows. So we've got 2 tools that were created by an external developer. Our minimal data entry tool, which is crucial to our mass digitization. And this is a photo of our lovely digitization team. For this, we capture very basic information to create the stub records, which is the filing name, the filing region, and the barcode. And the tool just sets those 3, the first 2, so the name and the region, and then the digitizer just scans all the barcodes that they're applying to a folder of specimens that fit those 2 criteria. And that's all written straight to the database, creating the collection object and the preparation records. So this is very quick and easy workflow for us, allowing the digitizers to ramp on through our collection and get it all databased. The batch determination tool is quite new for us. We've only had it in place a few months. But again, it's facilitating some of the key work that we do within the collection. We've been finding that when we've got very large numbers of specimens to deal with, either through loans or a visit to the collection or a big recuration task, that we needed a very rapid way to get those determinations done. So this, again, is very similar to the minimal data entry tool. You enter a few key fields, and there are opportunities to put some more detail in if it's relevant. And you just scan the relevant barcodes, and that will add the new determination to the records in Specify. So this is sort of facilitating us doing much more rapid work than we can sometimes do. And Specify is absolutely fantastic for doing these things, but we're a very small team and we have a lot of big requests coming in. And so we just needed that sort of much more rapid option that this has helped facilitate. That is a very quick summary of some of the things that we've done to embed. We are still working on bringing in more collections. If anybody is starting to use the molecular tables, we would love to talk to you. It's one of the next ones coming up. I know we've got a meeting on this just after we get back from Japan. So if anybody is using it in Specify, we'd love to hear from you. And Elspeth and Rob are both sat in the audience as well, who are also here from Edinburgh and are working with Specify. Thank you.
All right, we have time for one question, if there's any. All right.
Thanks, Robyn. That was great. I'm interested to know, when you have the multiple sheets as preparations, different characteristics of those, like, some might have flowers, some might have fruits. Where do you record those, and how would you record which one had a conservation event against it or a sampling event?
So in terms of the attributes, so we're using preparation attribute to record, I think it's preparation attribute. We're using one of the fields, I can't remember off the top of my head which one, to record phenology and some of that other specimen-specific information. We aren't using conservation event quite yet, so we haven't figured out how to tackle that one, but it's another one on my list to be looking at in the next year or so. And there was another part to the question, and I've completely blanked. So sampling, if we're doing sampling, we create a new preparation for that sample, and we're using the gifts table because we don't do gifts. So we've co-opted the gifts table to be our destructive sampling table, so that preparation is then sent out. So that's why we're managing it that way. And Elspeth. And we're using a field called derived from to record the barcode that specific sample was taken from. Thank you. I know what we're doing in the database on this.
Thank you.
Cheers.
All right, our next presenter is going to be presenting remotely. It's Nina from Uyghur State University.
Good morning. Do you hear me well?
Yep, we can hear you.
Good morning to everyone in this room. Could you see my presentation now?
Yep, we see your screen.
Yep. We are moving to other area, geographical area, but it is still Asia. The Ural Mountains are here, and we are east from the Ural Mountains. I am 4 hours ahead of the conference time zone here. The last time I had the opportunity to talk about the specify use in the northwest Russia for management of smaller collections was back in 2021 during Specific Forum. Now I will present some movements that we made since that time and our new achievements and directions. As an introduction, the history of biodiversity collections digitization in Russia started about 20 years ago, but the initiative seems reappear during the last 4 or 5 years with the support of the Russian Ministry of Science and Education, which gives grant for bioresource collection management. The current community around biodiversity data mobilization initiatives seems quite active, and many organizations have digitized their collections, but it also depends on the discipline. Like in botany, there are many herbaria digitizing their collections, but in mycology there are few fungarium collections which have been digitized, and this is the area of my occupancy and my interest for now, fungi or mycological collections, fungaria.
Could you go into slideshow view, Nina? Sorry to interrupt you.
Sorry?
Into the slideshow full screen mode for the presentation.
Full screen, sorry.
No, thank you so much.
Now, yeah.
That looks great.
There are more than 100 publishing organizations from Russia in GBIF and about 7 million totally published occurrences, and a third of them is preserved specimen data. So totally 46 organizations publishing preserved specimen data from Russia now, and as I researched, they have about 10, maybe 15 different online systems to manage their databases. Like the largest portal is the portal by Moscow State University in Moscow. called Neue Arc portal. It hosts mainly herbarium collection, but also some other disciplines. There are a few of unnamed institutional databases, and some organizations also use external products like Microtect and Specify, like our installation. Generally, larger institutions or collections tend to develop their own products, but there is no distributed software for management of collection data in Russia. Therefore, smaller organizations start to join larger portals, or they need to use distributed software. That is how we started to use Specify for use in smaller institutions or smaller collections. But as you can see, our installation in the 10th place in this rating of preserved collection organizations among Russian institutions. Our history of Specify use started about 10 years ago. Sorry, I'm missing one slide. Oh. With my personal, started back in 2015 with my personal experience for collection management. The development of regional installations started in 2018, and currently we started another initiative on discipline-oriented mycological collections portal for Western Siberia. This SIB Myco portal currently hosts or aggregates 5 collections from 3 organizations, and it will grow in the next several years, I believe, I hope. This regional portal is needed because the initiative on biodiversity data mobilization is better performed as a network of smaller nodes in a large country. And we started to create such a node. This includes also collaboration between organizations and people. This includes or yields promotion of open data model and FAIR principles. And of course, this includes data analysis and data publishing along this collaboration. And we will do this. Our instruments that we use in Specify are common instruments, but I will list some of them. Like we prepare own labels and reports. We are using barcodes. We are managing forms, using collection relationships, creating loans and gifts. And our attachment server is used for picture management, including publishing them in a GBIF. And we use Specify 6 installed on our university server, and manager using this to administer the installation. But regular users use Specify 7 to access it online. All our collections are published in GBIF through SQL query on a regular basis. And the most important development during the last 2 years, we started using DNA-derived data tables in our installation. Currently, we manage about 5 tables to store a sequence and trace files data, metadata, and attached files. We also created query templates for export DNA-derived data to GenBank in batch mode, to GBIF and other molecular data portals like Unite, which is for fungi. And several of our collections published in GBIF have a DNA-derived data extension. And finally, I want to present our educational materials, our educational work, which we perform in our regional Specify community in Russian language. Several years ago, I prepared Russian helpcast videos, and now we have 22 of them published on YouTube, including the last videos are concerned with publishing DNA derived data in Specify and exporting them to outer portals. Also, due to the complexity of storage and export of molecular data, we decided to publish a special protocol on DNA-derived data using Specify. It published on protocols EU now and could be used. It is in Russian language because otherwise it would not reach the target audience, and it helps a lot in this community. Oh, sorry. So in conclusion, we have some problems, but we also have the solutions. Our main problem is lack of education and IT support about Specify in Russian language. And the solution is organization of the tutorials in this language and organization of educational events. The second problem may be a lack of collaboration between Specify users in Russian language. And now I think that a discipline-oriented portal, mycological portal, would help because it would create collaboration between peers, between mycologists, and this communication would move this forward. And the last sentence here is suggestion maybe to organize an educational event on Specify in Russian during the next conference organized by GBIF in Kazakhstan, in Almaty, in the end of November. And I invite Specify team or other collaborators to join this event to organize a workshop on Specify in Russian language, to invite this community of this language speaking audience, and we will continue to use and Specify in this area. Thank you. Thank you for your attention.
Awesome. Is there any questions? All right. Thank you so much, Nina. I think it's very early there for you, right?
Yeah.
Thank you so much for being here. All right. Our next speaker is Theresa from Specify. So she'll be going over some really cool new advancements.
Okay, hi everyone. I am Theresa from Specify, as was just said. So I wanted to go over today how we are extending Specify 7 for geoscience collections. So Specify has been supporting natural history collections for well over 30 years. And now, thanks to a grant in 2021, obtained in collaboration with the Swiss Natural History Collections Network, or SwissColNet, we are expanding that support into geology collections as well. So rocks, minerals, meteorites, core samples, objects like that. So we made this decision for a myriad of reasons, but chief among those reasons were, first, when we were looking around, we didn't see any collection management systems, commercial collection management systems, that were geared for geology collections. There were collection management systems that supported it, kind of wink, wink, nudge, nudge, we support you, but nothing that really took into account their needs when it was created. Second, kind of what Zoe was alluding to, having everything in the same system in your institution really helps your institution. It helps your support to be kind of centralized and not spread out. It also helps create a community within your institution. So everybody can talk to each other, everybody can work together Not the least reason of which is a lot of our paleo people are also dealing with geology collections. So to properly support our paleo people, we need to support geology as well. And in some cases, it's actually invertebrates and geology. And finally, because doing this change actually helped us to make changes that we've been wanting to change for a while, but really haven't had the resources to do. So changes that help our entire community, all of our natural history people as well. And doing this helps them. So it was led by 3 people. Beta Hoffman, who's a curator at the Natural History Museum of Bern, which is one of 4 institutions, Swiss institutions, that we've been working with. We've been working with Bern, Basel, Geneva, and Lucerne. I'm sorry if I pronounced that wrong, I always will. Jim Beach, who's the director of Specify Collections Consortium, and Ben Norton. There were 2 phases to the project. Ben Norton led the first phase. He created a conceptual data model. He went out and looked at what data is collected for geology collections. How do you support that data properly? What do geology collection managers collect? What do they say about their data? And during that time, Specify staff really focused on community engagement. So we went out and we interviewed 20 different institutions, talking to their geology collection managers, kind of doing the same thing, saying, what do you use? What problems do you face? What would you like to see? What would you not like to see? How is your experience going? And we created the GeoSpecify Advisory Committee, which is made up of 40 individuals. If anybody wants to join, let me know. But they're individuals from around the world who have geology collections in one way or another. They're either geologists or they're paleontologists who also have geology collections. And we talk to them about their expertise and their insights, and we tell them what we're doing and get their feedback. We are now in phase 2, and that's led by us. And we are continuing our community engagement, but really this phase is implementing the changes. So this is where we actually create the software that's going to support the geology collections. So one of the difficulties we're facing during this phase is, like I said, we want everything in the same system. So it's going to be one data model. So we're going to still support natural history collections as well as geology collections in the same data model. So finding that balance of we are properly supporting geology collections and taking their needs into consideration while also supporting natural history and making sure we're not dropping the ball on that. So while we've been talking and debating and, I'll be honest, arguing about what changes need to be made, we came up with 5 main areas that we need to focus on in order to properly support geology collections. We need to focus on the collection object types, identifications, collection object groups, stratigraphy, and age. I really need a better place to put my papers. Okay, so we're going to start with collection object types, which, as the name suggests, are different types of collection objects. So we see this in natural history a lot. You will have a botany collection that has vascular plants and mycology and algae. You will see vertebrate collections that have fish and mammals and birds all in one collection. Now, geology collections is prevalent throughout this. You will frequently have a geology collection that has rocks and minerals and meteorites. And if you're not in geology, you might not realize those are really, really different, and they really document different data. So we had to think about the best way to allow different objects in the same collection and what we need to do. So the first thing we came up with was conditional forms, which, again, as the name suggests, are forms that are based on a condition. So in this case, the condition is collection object type. So we're going to allow different forms in the same collection based off of a collection object type. So you can start your form and say, I'm entering a rock, and see a form that just has your rock fields. But if you're entering a meteorite, the fields are going to be different versus a mineral versus a fossil. And all of those forms can be slightly different. They can be the same, or they can be different depending on the collection object type, which streamlines data entry because you don't have fields that aren't relevant to you. It also reduces the tendency or the likelihood that people are going to make a mistake. You're not going to accidentally enter your rock data into a mineral field. So when you're searching for it, you're searching in the right places as well. One of the other really important aspects of this is if you have different object types, you could have different numbering sequences. So we had to account for, in one collection, you could have a rock number 1, a mineral number 1, a meteorite number 1, which if you are familiar with Specify, we do not allow. Well, now we're going to. You can have your collection object type and say, my rocks use the rock sequence. My minerals use the mineral sequence. So when I say material type mineral, it will go to my mineral sequence. So I can have a mineral number 1 and a rock number 1. Or it's also frequent that everybody uses the same sequence. So you can say, actually, my rocks and my minerals and my meteorites are all using the geology sequence. But my paleo collection, they use a different sequence. So these 3 object types use this sequence, and this one uses a different one. So you can properly document and number all of the objects in your collection. One thing that is unique to geology collections that natural history collections don't tend to have is they have different identifications, though. So even if you do have birds and mammals and, I can think, just give me a second, birds and mammals and fish in one collection, you're all still using the taxonomy tree. But in geology, they have different classification systems. So we need to account for different classification systems in the same collection, which again, is completely unique for Specify. So now you'll be able to add different classification trees. You can have your Dana, you can have your Struens, you can have your IMA approved classification. We've also worked with Mindat to use their API to have their classifications. And you can have each one have a separate tree. So when you're entering your data, you can say mineral type mineral or material type mineral, use my mineral tree, and it will just search your mineral tree and give you back the results that are in your mineral tree. However, later on, when you're doing a search of your collection, you can either say, I only want to see my mineral tree data, or you can say, just show me the classification. I don't care what tree it's from. I just want to see it. So we're letting you search either way. So moving on to collection object groups, which again, I know we're brilliant at names, are groups of collection object records. So this is really, really prevalent in, again, geology collections. We see it in natural history, where you'll have a sheet that has several different specimens on that one sheet. So that's really common. Or you'll have a slide that has a bunch of different objects on that slide. In geology, it's really frequent to have a compound specimen, where it's one rock with lots of different parts to it. Like this rock that you see, which is actually from the California Academy of Sciences. I took the picture at last year's Spinach when we went through the collection, so I hope you guys don't mind that I took your picture and I'm using it. But you can see this is actually muscovite with quartz and, wait, I wrote it down, muscovite with quartz and feldspar in it. So that's 3 different types of objects in this one specimen. So you have to create 3 different collection objects to be able to properly document all of that different information, because it's, again, entirely frequent to have a mineral that's in a rock. Well, you need 2 different classification systems to document that, so you do need 2 different collection object records. And then the collection object group, we call it COG, will put all of that information together, and it will allow you to properly document that entire specimen. So you can see, like in this, each one of these lines is a collection object record for each different part of the mineral. And you can say the metadata that's really important for geology collections, like what proportion is that particular mineral or rock of that specimen? What's the relationship? So you can document, is it in it? Is it on it? Is it with it? So you can properly put that on the label as well and construct that together. And again, we really took into account numbering for this. So frequently, that object would have 1 number. So if it's in the COG, you can say, all of these collection objects are going to share the same number. So just assign the same number to anything that I put in this COG. Or it's also frequent to give all of the objects there a different number. So if you have a sheet, say, that has different herbarium specimens on it, each one might get a different barcode. You can say each one has its own number, or some of them share a number. Or you can say, again, that they all have the same number. Moving on to stratigraphy. So we are adding a new tree to Specify. We're going to add the tectonics tree. It's going to follow all of the same rules that our current existing trees follow. So you'll be able to move, merge, synonymize, all of the same things that you can do. And we're also adding some magnetostratigraphy dedicated fields, so you can document magnetostratigraphy as well. And you know what? I forgot my favorite part. I have to go back. I'm sorry. I was in such a rush to make sure I didn't go over time. My favorite part of COGS, my favorite part. And when I talk about allowing changes that affect everybody and benefit everybody, this is the part I'm talking about. So one of the benefits of COGS is you can say all of these are part of the same object. It's this one rock, it's this one sheet. So when you go later on to say, I'm going to loan this sheet, I'm going to loan this rock, I need to loan this quartz to this person, it goes, oh, you mean the muscovite and the quartz and the feldspar, and it automatically will add all of that to your loan. And then it will update all of the records to say, all of this is on loan as well. So it really helps all of the collection managers, and it's something that's been requested, and we've tried, and it's going to come out now. Sorry, stratigraphy. So next is age. We're adding several tables for age. So you can document both absolute age and relative age. And you can document multiples of these, because you might have multiple different absolute ages, multiple different relative ages for the same object. So you can have your age of sedimentation, your age of metamorphosis, your age of inclusion, all of that properly documented and associated with your object. And the really, really cool thing about this part is we're also going to work on changing how the search function works. Because now that we have age in several different places, how do you search that? If I'm looking for something that's 260 million years ago, where do I search that? Do I search that in absolute age? Do I search that in relative age? Do I search that in stratigraphy? Where do I find that? So now we're going to change the rules of the search to say, I'm looking for something that's 260 million years ago. And it will look at the Permian. It'll look at the Permian age and go, oh, well, the age range for Permian is before 260 million years ago and after 260 million years ago. So you meant those objects too. So we'll bring back anything that says 260 million years ago and anything that's Permian, because that's within the age range you're talking about. And the opposite will work as well. So if you say Permian, it will look at the age range and say, oh, 260 million years ago, that fits within it, and bring that data back too. So I can't believe I actually made it on time. Okay, so thank you to Swiss Colnet. They've been amazing. We work with them constantly and all the time, and we really love working with them. And NSF, who funded our original programming for Specify. The people who worked with us and did interviews with us, we really appreciate you guys. We needed that help because we are not geologists, and the people we worked with gave us a lot of insight, and our GeoSpecify advisory committee was really helpful. We loved them. So thank you.
Are there any questions for Theresa?
Oh, right, stay here.
All right, we'll be around for the conference, so just find us if you have anything that comes to mind. Thank you so much for being here, and whether you're a Specify user or not, thank you for your interest and your support. This was really great to hear from everybody, so thank you to the speakers, thank you to the attendees. Thank you so much. This is very brave. I don't know if I would have volunteered today.
Yeah, we're not going to, so this is every moment of
Seriously.
some also mostly coming from our collections, but they are also managed to trying to work out how to all the information and then links back to that. So we're trying to same with that, we're trying to link well the loops rather than bridges. We're not recording actual DNA sequences or runs, sequencing runs, we're not without playing around with it. Feel free to get back to have a better idea. But I can give
Yeah.
I can put you in touch with our development. So we can use the 95 platform that is basically, so our two systems actually change data. So build a 95 platform that monitors the political specified